Hello, my name is John Ketchersid, as you probably already know, based upon the name of the channel. Hey, I have a few little rants to kick off here, based on logic and understanding and presently known science. First thing, of course, is battery-powered cars and why it's not a good idea. I'll do this quickly. In 1929, most of the vehicles that were used as taxis in New York City, a little over 98% actually, were battery-driven or pile-driven vehicles. Now, back then, power generation took place very close to where it was being used. That's not cost-effective, as we know from our giant network of high-tension stations and the very few, relatively speaking, large power generation companies and facilities. So when you transport electricity over long lines, even thank you to Nikola Tesla, over great distances with minimal loss, every stage of that transmission still results in loss. Let's just say, for instance, in Atlanta, we're using power that's generated in Alabama, Birmingham more specifically. The power goes from the power genco, hits the primary distribution station just outside the power generation facility. At that point, it's already lost about 10% due to thermal energy waste, resistance, Fermi spin-off, and electromagnetic generation, or electromagnetic radiation emissions. So, we've done a lot to increase the efficiency, but still 10% is 10%. Now we get into the national grid, where more electromagnetic radiation and efficiency and all this other stuff results in another 15 to 20% of loss. Then we get to the municipal distribution stations, and those make it to the neighborhoods, and then the substations in the communities in the forms of small transformers, relatively speaking. And totally, we've now lost about 60 to 75% of the power that was generated, more specifically the fuel that was used to generate said electricity. And now we're going to go about cramming that power as fast as we can into batteries that are in a vehicle. And those have become extremely efficient, that's true, but nonetheless, it's still an absurdity to think that they are 100% efficient. A massive absurdity. So now we'll just say 70% loss between the power substation and where the vehicle is being charged. Now, in the case of a gasoline vehicle or internal combustion engine vehicle, you take the fossil fuel and you distribute it in very close proximity to where it's going to be used. This does have a transportation cost and a bunch of other stuff, but what does matter is you're only losing about 15% instead of 70%. Okay. Now, I do have a great appreciation for electrically powered vehicles, and more importantly, I can see the great value of hybrids and all the other little trinkets we add on, such as regenerative braking, etc. When you stop 2,000 pounds of steel from moving at 30 miles an hour in any distance, you're going to be able to generate some power off of it. All of that aside, we don't need to create electric vehicles that use batteries that are charged from large-scale fossil fuel burning, CO2 generating machines, systems, as it were. Pardon my speech, it's a bit impeded due to a number of physical ailments that I've experienced. Anyway, if you do a Google search for my name, My last name is Ketchersid, Ketchchersid, as in. And my first name is John, middle name Wesley. So John W. Ketchersid. I've had several suffixes. The most recent is PhD, although I should say PhD squared. Computer science and microtribology. Anyway, the fact is that in 2011, an organization was built, investment was taken in, a machine was built. We didn't meet our deadlines, but that's of course because we didn't manage the expectations of our investors. So, when you're doing something that's never been done before, as Lawrence McKinley would say, you don't know him yet, you will, I'm sure. It's hard to set a timeline for accomplishment. Pardon the lighting, I'm sitting in a vehicle in a parking lot so that I'm not dealing with too much noise, and I'm not impeding others from enjoying their life. The machine in question is called a magnetic reciprocating engine. It's not a motor, it is an engine. Motors have measures of efficiency, as do engines. When you get in your car and you turn the key, the little tiny battery under the hood there produces the electrical charge necessary to rotate the starter, actuate the fuel pump, and provide spark via the ignition system to cause another form of energy to be utilized, just like in a steam engine. If you got on a steam engine from, say, the 20s and went into the driver's station, I guess you'd call it, whatever, the cockpit, hey, you would see that there's an ingot of metal that is a valve which channels steam from the front side of a cylinder, pressing against a piston, which pushes the piston back. And then, as the circuit is completed, the ingot slides to the other side, resulting in the pressure of the steam entering into the rear of the cylinder, which presses upon said piston, resulting in forward motion of the piston. And that's where you see that lovely wrist pin and connecting rod, which takes that huge amount of energy that's being applied to the piston and directs it toward the, directly to the wheel, actually, the drive wheels of the steam engine, or the locomotive. So, in an engine, you're not harnessing the energy that you're putting in directly. You're using that energy to control a more substantial form of energy. An electrical motor, for instance, will take electricity via induction, which is very lossy comparative to other systems, and very efficient in comparison to others. But the bottom line is that electric motor converts electrical energy to rotational energy with a given efficiency or loss. So, avoid induction if you can. So, where do you think a magnetic field comes from? And I'm not going to say a magnetic field. It's like, sorry, it's more like the magnetic field. Every atom, every subatomic particle, every molecule, every dog is possessed of the magnetic moment of a material. You can go ahead and look up magnetic moment. There are many, many volumes written on the subject. But a fellow named Faraday once posed a very interesting question. He said, is it the matter which results in the magnetic moment, or is it the magnetic moment that results in the matter? It's kind of important. Furthermore, if you have two photons traveling along a path, let's just say along the x-axis, one behind the other, of course they're traveling at the speed of light. If you impact the photon in the rear, you'll notice that the photon in front of it also moves, quivers. Why might that be? Because the space between those two photons is changing at the speed of light, which, according to present understanding, cannot be exceeded. Well, this is why the engine which we built, not what you would expect from an electric motor, but rather from an engine. Perpetual motion does not exist. Okay? I've never believed that it did. For that to be true, then the universe would not function as we know it today. Well, there are several points that are presently missed, and I've got to cut this video.